Guys, I welcome you back to another episode of Further Mathematics for SS3, and today we are going to be dealing with probability distributions. Now, what about probability distributions? It has to do with the basically distribution of different samples of data, and this data they have their different probabilities, right? So now we are going to be talking about three major probability distributions here. They are going to be the binomial probability distributions, the Poisson distributions, and also the last one is the normal distribution. So for the binomial distribution, the formula you'll be basically using is the formula it's a particular formula that is tied to permutation and combinations, and basically I'll be giving an example to show the formula. So in this example, we are told that all a nail producing machine produces 30% defective nails. So construct a probability distribution for 4 nails and selected at random from this distribution, and then find the probability of getting exactly 2 defective nails. So we are looking for the probability distribution for 4 nails. So basically, what we are dealing with here now is the probability that the nail is defective. So that will be A. So that event of being defective is A. So now we are looking for the probability of A. But then the probability of A is that because a nail it produces 30% defective, right? That's 3/10 or 0.3. Then the probability that it is not defective, PRB, let it be equals to 7/10. So that means in this case we'll be setting up a distribution for 4 nails. Now that 4 nails, it is kind of like an exponential because it increases exponentially. So that means we'll have A plus B, because there are 4 nails, there are 4, n is 4, is power 4 equals to, so we could decide to expand it using binomial methods, binomial theorem. So that will give us a correction of 1 4 6 4 1, right? That's A is power 4 plus 4 A cube B plus 6 A square B square plus 4 A B cube plus B is power 4. So this corresponds to what's called again? Pascal's triangles of binomial theorem. So now we are told that we're looking for exactly 2 defective nails. Now in this case, you are going to look for the case where you have an exponent of exactly 2 on the case of A. So where does A have a power of 2 here? So this is where A has power of 2. So we circle it here and bring it out. That's 6 A squared B squared. So that means in this case we are going to be substituting our probabilities here and we'll solve for the answer. So that means 6 times A itself is equal to 3/10. That's the probability of it, 3/10 squared, times B itself is 7/10 squared. When you solve this, you are going to get your answer, and that answer will be the probability of getting 2 defective nails out of 4. So that being said, let's move on to Poisson distribution. Now in Poisson distributions, we have a particular formula that is Euler raised by minus what's called again, lambda or whatever, times dot lambda r over r factorial. So in this case, what you are doing here is basically you are dealing with the natural log, which is Euler's number, and which is the negative power of the what's it called? What do we call this? I don't know the Greek name for that, but it's basically a symbol, and that represents the variance, or we call it the mean. So the Euler's number is the negative of the mean, multiplying the mean with the number of cases. The number of cases we are dealing with. So for example, we will say 5% of items manufactured by a machine are known to be defective. If 4 out of 100 are taken randomly, find the probability that they will be defective. So in this case, your number is 4 out of 100. That means your number, which is the number of defective nails, will be 4, right? That means, and also your probability of getting a defective nail is, because it is 4 out of 100, so 4 out of 100 are taken randomly. Find the probability that they will be defective. So, but 5% is defective, right? That means your P, basically your mean is equal to the product of your number of nails and the probability of getting a defective nail. So in this case, we have a number of nails. Then we are told that 100 nails, the number of nails, multiplying by probability, which is 0.05. So our mean will be equal to 5. So that's the mean of nails. And then our we are finding the probability that 4. So that is 4 nails. If 4 out of 100 are taken randomly, find the probability that they will be effective. So our case R here will be 5. So we'll simply plug in our values. E Euler's number is power minus the mean, which is 5 times the mean 5 times 4 over 4 factorial. When you solve this, you are going to get your answer, which will correspond to the approximate probability for the getting 4 defective nails out of 100 taken at random. So let's move on to the last concept for this video, which is the normal distribution. Now for the normal distribution, it is quite simple, except that we have some actual needs to do some bulky calculations with tiny numbers. So, but apart from that, the normal distribution is quite simple. Normal distribution mostly looks like this, and you are dealing with a concept where you need to calculate the average of probability of an event occurring. So the average stands at here, and for the normal distribution, when it is normalized, it has a mean of 0. So in this case, we have a mean of 0, and this 0, and basically when we look at this, it looks like a bell curve. Right now, this normal distribution, we have what's known as a standardized normal distribution, and for this standardized normal distribution, we basically have it is unimodal. It has only one peak. So now we have a portion of it, like 68% of it occurs between one standard deviation from the mean, 68%, and then we have 97% occurring between two standard deviations of the mean, and so on and so forth. But that is not the main thing. You can easily get that from your tables. The main thing is how this calculation works. Now, this calculation works in a simple way. For example, if you are given a simple question that a random variable, okay, let's say let me give a very tough question. So we have okay, good. So now we have a question here. If z is normalized for 0,1, so find the values of a which satisfy the following. P of z is lesser than a, probability of z is lesser than a, and that is equals to 0.75. So in this case, we are looking for the probability that find the value of a which satisfy this equation. Now there's what's known as a probability, as the normal probability logarithm table. No, not only logarithm, but it's just normal values. So you are going to use that one either in forward or reverse to get either your probability or your variables. So in this case, we have a variable of 8 to 4, and then z is the standardized values. So in this case, looking at it from very carefully, we have we're looking for a which satisfies this. So that means we're looking at this z is a particular term for a term which involves the variance of the distribution. But now we have the a, which is our variable. Now this variable, let's pick it at any particular point. Now from this mean to a will be equals to 0.75. Okay, that means we are looking for a particular point in which it's equals to 0.75. But you should know that half of this curve is this curve has an area of 1, so that means half of it is 0.5, and then we need 0.25 here. That means we'll be taking 0.25. So if this is a, that means the probability of a is equal to 0.25. So all you need to do is you just go to your tables and look for the inverse of that, and you get a equals, from tables you have a equals 0.674. So that is basically that's basically it. So basically these are the concepts you will need to understand for distributions like this. Just in case you might need some deeper concepts, you can let me know in the comment section of this video. Thanks for watching.